This presentation was recorded at MVCConf. For more content like this, go to www.mvcconf.com. JetBrains, the leading vendor of professional development tools, now offers a range of new products for .NET developers. In addition to ReSharper, the top-class productivity extension for Visual Studio, you can now use .cover to run coverage analysis for your applications, .trace to find performance bottlenecks, and use TeamCity and UTrack for a perfect combination of continuous integration and issue tracking software. Go to www.jetbrains.com for more information.
Can everybody see that? All right, so today we're going to discuss distributed applications and MVC. A lot of what we're going to discuss today will apply to both MVC and web forms, with the exception of how it interacts with controllers in the front end and so on. So any questions that you might have, think of them from both perspectives. In this session, we're going to take a look at a high level of what how to go from a demo-style application. And when I say a demo-style application, I'm referring to what everybody's seen, be it in a blog post or podcasts, etc., where they start with a fairly flat application. Most of the logic is either in a code behind or in a controller type fashion, where you've mixed both data access, business layer, domain objects, and all those kind of concepts all into one ugly blob of code. As we go through today's session, we're going to actually refactor that demo application through various different patterns and ideas until we finally get to a point where our application is ready to be distributed to multiple servers. We'll go over what distribution means and how that impacts the performance of your application, and then we'll actually start going through the refactoring process. So starting from our demo application, again, it's just going to be a standard MVC application when you start a new web app. Everybody's probably seen it. You have registration and login capabilities. You have the home controller, which has the home page. You have About Us, those kind of things. So we'll start there. What I've done is overlaid some e-commerce concepts on top of that. And so in our application, what you'll see is the home page now lists a bunch of products. You can click a product, see the details, and you can also go into a search box and search for products. So we have two different types of pipelines. We have the catalog process, which actually is in charge of displaying products, and we have a search process, which allows you to drill in and find a specific product. As we go through, the next step will be to get into separating the concerns and responsibilities and how we go about doing that. Following that, we'll get into logical separation of your code. Then we'll get into physical separation, then dependency injection. Then we'll look at inversion of control, and in this case, we're going to use structure map. And then once we've gotten that far, we'll actually be able to create a distribution. Actually, it'll be a distribution tier, but and then we'll be able to slip that in and see how that works. So what does distributed mean? It's basically the ability to have more than one server handle requests for your application. And this isn't to say that you take a single application and you toss it into a cluster of multiple servers, but rather the ability to take a piece of your application, have it processed by one set of servers, another piece of your application could be processed by a different set of servers. It's the idea of being able to scale horizontally or scale out rather than up, which is vertically. And so what that would mean, to scale vertically, say I've got an application that's running on a server or a set of servers, it's starting to bog down either because I wrote bad code or because I've got so much traffic that the server, the infrastructure, is just not able to handle it. So in order to scale up, I can just throw more RAM at it, more processors, etc., and eventually you hit a problem. You either hit a budget issue or you just can't scale up anymore, in which case you eventually need to scale out and be able to take the slower piece of your application and distribute that off to some other application or some other set of infrastructure. Some examples of things that might be distributable is the search application or the search part of your application, order processing in an e-commerce environment. Maybe you're in a social network environment, in which case you might have blogs, you might have forum or chat. Those are all different segments of your application that might be better suited in different types of infrastructure. So the question usually comes in, why scale out rather than up? There's the obvious issue of cost. As you try to scale up, that means that you're trying to add better hardware, more RAM, faster processors. That in and of itself becomes a cost issue. Whereas if you have the ability to scale out, you can actually throw cheaper hardware at the issue, having more servers within a cluster, and those servers could just be low end, so your cost starts to decrease. But then there's the other side of it, where you have a web server where your web application is running. That web server may actually be doing all sorts of different types of processing. Some processing might be memory intensive, some might be disk intensive, etc. And so in that case, if you're in a scale-up environment, you have to address all of those things regardless of if you actually need to or not. Whereas in a scale-out type environment, you could have a low-end processor environment with a slow disk that actually has a whole lot of RAM. And in this case, you'd use like Velocity or Memcache or something like that for a cache type environment. But then when you get to database and something more disk intensive, you might actually need not so much RAM, but more processing power and larger hard drives or disk arrays, etc. So the ability to actually take segments of your application and put it into infrastructure that's more appropriate for that type of processing is really what distributing your application is and why you'd want to be able to go that route. So again, our demo application is just the canned MVC style application. In this case, the domain model is non-existent. Business logic is scattered all over the place. Data access is going to be linked to SQL. However, if you've used Link to SQL, you know that Link to SQL is in charge of generating your entities or the model that you actually work with. So in order to use that model from your view and in your controller, you have to actually reference not only your data access layer, but the framework that is Link to SQL. This becomes an issue that, if you ever wanted to actually swap out Link to SQL for Entity Framework or in Hibernate, you'd actually have to do quite a bit of surgery to go in and pull that out and put something else in its place. So we'll go ahead and take a look at the code. Let me share my desktop here. So what I have here is basically 7 iterations of the same project, the first project being the demo application. As we progress throughout the talk, we're going to see what has happened after a set of refactorings have occurred. We'll be able to go into the code and see the differences in there. One thing that's kind of important, if you do have questions along the way, rather than waiting to a pause point or towards the end, if you could actually ask them in real time, it'd make a lot more sense because the topic will change as we move along. So in a standard demo type application, a majority of your logic actually gets stuck into the home controller. It's where the request is first processed, so it's the first place that logic starts to stick. If you don't have a business layer or data access layer and you don't have a domain, then the majority of your logic will actually go in here. So what we're going to see is we have a home page index. It creates a collection of products which are generated by Link to SQL. We actually create a connection to the database. We query for a list of the entire set of products. And in this case, obviously that's a bad design. We only have like 6 products in the system. So, and then we immediately return that list of products directly to the view where we iterate through them. And I'll show you that in a sec. We then have a search method or action. In this case, same thing, list of products, connection, query, etc. So what we see here is, we have this domain concept, which is the product itself, the entity that we're working on. We have some data access stuff where we're actually performing the query. In some cases, I think we had some business logic scattered, so I tried to come up with a simple idea of maybe what would be business logic. So in this case, we're doing some validation. The product detail action takes in an ID, which is a GUID off the URL, but it could be any number of things, so we need to actually check if that actually is a GUID. And if not, we redirect to the home page. If it is, then we can move on and actually query our system. So this would be a case of business logic, which should be wrapped up downstream somewhere in some kind of a service class, what have you. Let's see. So let me dig into some of the display aspects. So So in our homepage, we don't actually have a whole lot going on here. We're rendering a partial view, which is product results. Reason I did that, product results shows on the homepage and the search page. So within MVC, even in a demo app, you can still kind of embrace some kind of good standards. So we have, let's see, shared. We have product results. So product results takes care of formatting a table for me, iterating through all of the records that are passed in or the products, and then determining, do I need to close this row or not. Not a whole lot going on there. And then we finally have the product result view, which is another partial view. So this particular one, again, we kind of see some business layer that's kind of leaked out into our view. We're actually trying to determine logically if the product is on sale or not. We do that by determining, does it have a discount price or not. If it doesn't, then we assume that it isn't on sale. If it does, then we assume that it is on sale. We're also taking care of the formatting of the display. And if you're in a large application, this too should always be considered a business logic, because if you're trying to format your application for an English speaker versus a Spanish speaker, you don't want to have to come out to your UI and figure out stuff here. So this is another thing that could be put into your object model to take care of anything. Now, in a demo app, obviously we don't have to necessarily worry about localization, but you still want it in the right place so that if down the road you do need to take care of that, you have it centralized and you can go ahead and take care of it without a problem. Again, we're displaying the discount price. We have to actually convert this in a way. Same with retail price. So these are things that we'll want to clean up as we go. I don't think there's anything special other than this. So we'll go ahead and run the application and see what we're working with here. So homepage, as you see, we just have a list of products based on that partial view we looked at. Some products are on sale, some products are not on sale. Clicking on any of the products, you get a detail page view. Now to demonstrate that business logic, we can put a string here, which obviously won't translate to a good, so this should actually redirect us somewhere else. It took us back to our home page. Then we can actually do a search. The search is going through and trying to isolate products that fit that string. Again, same kind of flow. There are other aspects such as the logon and registration stuff. I didn't bother with any of that. So these three primary things or four primary things are what we're going to look at as we build on ourselves. Okay. So I'm going to flop back to my slides. All right. So why are these demo applications bad? One point that I didn't cover in here, and I kind of kick myself for that, anytime you have somebody talking about how to do something that's really great, but then they do it in this demo type environment, what you're kind of doing there is promoting bad code, bad design patterns, etc. So people might latch on to this really cool widget that you're featuring, but the thing that we also don't understand is that they're latching on to the environment that you're also displaying it in. So that's bad. Inside of here, another problem that you might have is heavy code duplication. So say you create several pages. Those pages are accessing the same business logic, the same data access, but you're actually doing it in different sets of files. The problem you have with that is that if you need to go in and make a change to your business logic, how you process discounts, something of that nature, you have to actually be sure to go in and make changes across different places. So what you run into is an environment where your business rules are now out of sync. So some people may be ordering product A, getting a huge discount. Other people might be getting no discount at all, and that's obviously bad. Also, you have tight coupling in this type environment. Tight coupling is a problem in that it creates less flexible code. The less flexible your code is, the less likely you are to change it, even if it really needs to change, be it an update, etc. You create unforeseen ripple effects when refactoring. So anytime we're going in to refactor our code, maybe the class name no longer makes sense for what it's doing. We need to have confidence in our code so that we can go in and make these changes without fearing breakage throughout the rest of our application. So if we have instances where all of this logic is scattered all over the place, not only is the problem of refactoring amplified, but also what is being impacted by what you're changing. Any type of application like this where we're mixing concerns as heavily as we are, not only is it not easily testable, it's probably not very testable at all. You're going to write as much code in mocking utilities and so on as you would in your actual application. Deployment options in this type of environment are fixed because all of your logic, your different concerns are all squished together. They all have to be versioned separately, or I'm sorry, singularly. So the entire application gets a version. If you make one change, the whole thing needs to be pushed. Whereas if we get further down the road into more of a tiered type environment, we can freely push out presentation layer changes separate from data access layer changes. So the next refactoring that we're going to look at doing is moving more towards separation of concerns and single responsibility principle. I'll just read these definitions. Separating the program into distinct features that overlap in functionality as little as possible, encapsulation, modularity, and information hiding is what makes up separation of concerns. So the concept here is, at a high level, you have business logic, you have data access, you have domain logic, you have presentation logic. Those are obvious buckets to start separating your different areas of code into. Single responsibility principle kind of builds upon that, breaks it down a little bit more. Every object should have a single responsibility, and that responsibility should be entirely encapsulated by the class. Only one reason to change for that class. So a situation here might be, and we'll see this down the road, I'll build on this. So we have simple data access for our product entity in our database. So in that case, we need to be able to get a product by ID. We need to maybe add the product. The only thing that could really impact the responsibility of the class that will eventually do this would be the underlying product. Whereas we'll also need the ability to search for products. This is still, in our implementation, interacting with the database. However, it may interact with a Lucene cache or a file store or something of that nature. It has a slightly different job. It's not purely data access, so that might be something that we might want to make a more granular responsibility, therefore a more granular class. Why would you want to do these things? This definitely makes your code easier to work in. It's more manageable because what we have here, if you take our current home controller, you have to actually scroll through that entire home controller to get an idea of what it does. And before you go in and refactor anything, you should definitely know what it is that you're working on. If you follow the single responsibility principle, what you end up with is very specifically named classes that define exactly what the responsibility of that particular class is. Usually you get a much smaller set of code in that particular class. This obviously makes things more reusable. We know exactly where to go for a specific thing. Refactoring starts to cause less ripple effects because things are in their buckets. So now we've actually started to move everything together. We no longer repeat our logic, and it is in one container, so anything that's directly using it is probably the only thing that would feel any ripple, although it shouldn't technically feel too much. Code becomes more stable because you have your business logic isolated into one container, your data logic in a container, and even more specifically, you have specific responsibilities down in a more granular container. That ripple effect again is much smaller. Let's take a look at the next set of code for this particular refactoring. Let me swap back here. So we'll look in the same places that we started off before. We'll go into the home controller. Let's see, actually it'd help if I was in controllers. So inside the home controller, we still have the same set of methods. Let's see here. what we've started to do is move things out. So now we actually have a product repository. We have a product search repository. We will actually have a product class, and all of these things will be used inside of here. So what you'll see, rather than actually having the data access logic directly in this action, we actually can out to the search repository in a method of products. And what that allows us to do is reuse this across multiple aspects of our application if need be. It is still a demo application, so it's a fairly small application. But as you can see here, exactly same logic that we had. It's all contained within a product search repository. Repository is just a design pattern that allows you to not necessarily isolate purely your data access, but more your infrastructure access. So when you go out to web services, when you go to the file system, etc., you might consider using a repository pattern for that. And then we have product. And what product is doing, we've started to move up our business logic, so determining what the current price is. And so we had that logic before in the view that said, is this a discounted product or is it a regular product? So we can just call this easy property, which is a partial class off of our link to SQL. We have a display retail price. You'll see that the formatting for the currency type is done here. So if later on we need to support localization, we can easily do that here. We have display discount price, and rather than doing the check of being on sale, we can say, is this on sale or not? So we have that logic going on here. So actually I could replace this with that property call. Haha. Let's see. So home controller, basically everything has been moved into product. We still have a little bit of business logic here, which we will move out in our next iteration. Let's take a look at our view here. So in our product result view, we're no longer actually manipulating business rules directly here. We're calling the property off of the product, which we're passing into the view, strongly typed view. So if it's on sale, then we're going to display the current price. We could have easily just displayed the discount price because we did that check. However, we wanted to change the format based on if it was on sale or not. So current price is going to be in red, or current price being a sale price, and regular price will be over here without any special formatting. And that is the majority of this guy. I'm not going to run the application because there's no physical difference in how the app runs. It's purely a structural change. Is there any questions at this point? Get ourselves ready for the next iteration there. Let's see. So logical separation becomes the next major refactoring of what we want to do. And there's frequently miscommunications between what a layer is and what a tier is. A lot of people use them interchangeably. Basically, a layer can be contained within a tier. A tier cannot be contained within a layer. That's probably the easiest way to keep track of it. A layer is a logical grouping of code that have a common concern. So you might think of this in the terms of namespaces. So if you had a core namespace or BLL or business logic layer, whatever you want to call it, everything that lives within there should have a common functionality underneath that namespace. If you move from that, say you have core.search, everything that lives within the search namespace or your search layer should work and interoperate with that same concept. Layers generally communicate directly with neighboring layers. However, you generally don't want to communicate upstream. And when I say that, the presentation layer might communicate with core to data access, but you wouldn't want your data access to communicate back to business layer or business layer to communicate back to presentation layer.
Andrew, we have a question from Demetrius. He's asking, formatting in a model, isn't that a view concern?
Well, so formatting from, let me swap into code here. It's actually, I closed it. Wow, I got ahead of myself. So formatting from the point of view of how a table works, or formatting how a font looks. Those kinds of things are definitely a view concern. However, when you talk about adding the $ to a price of something, yes, that's definitely a view concern. However, when you talk about a large application where you want to start doing localization, meaning you want to support multiple different countries, each country has a different way of formatting a date, representing time, displaying money, etc. So in that case, you probably want to push that particular formatting up to your model so that it's centralized, so that your view can access this business logic. The business logic being, is this user in the US? Okay, display $1. Is this business user in Europe? Maybe display whatever lira looks like, etc. So this is one of those cases where it could be confusing. I could definitely see where that would come up. So in this case, we're not actually saying, display this discount price as red with a fancy font because it's super special. All that we're saying is that this is money, and we do want to format it with a $ with .00 to represent 2 decimal places for the actual price. We wouldn't want to represent this in the view as we did before. Let me pull that up again. And the reason being for that is that we would have to do that formatting all over the place. So in this case, we have display current price and display current price. I would have to actually replicate that logic here, and I did in the demo application, even though I was just displaying $1. In this case, I can push that formatting up one level, and that $1 can be centralized. When I talk about the localization logic, in that case, it's more than just displaying. It's actually a lot of business logic to decide on what and how it should be displayed. Does that make sense? Okay, I'm going to switch back to slides. So back to layers. So another concept of layers, layers run in the same process, and that's primarily the point of this discussion. Tiers actually can operate inside of different processes. By process, it could be different threads, it could be different app domains, it could be different servers, etc. We'll take a look at that. So why use layers? Layers generally create a more maintainable code base. They also get you one step closer to a tier. There's not necessarily any huge performance implications. It definitely doesn't have any performance benefits other than it's much easier to work within your code. It's purely a structure of the environment that you work in. Let's take a look at the code. Okay, so the code doesn't necessarily change. There's not a whole lot going on here. What we've actually done, we're still working within the web environment. We're still working within the MS-MVC concept of a models directory. And then inside of that, we've extended the namespace. So we're now at mvcconf.distributedapplication.web.models.core. Core becomes the layer that we're working within, and you'll see a couple of added classes, and we'll figure out what those are in a sec. Data has our data access. You'll also see that I've moved the link to SQL context in here, and this has our product. So our data access generated product now lives in a different namespace from our actual product. The reason that we've done that, this is to allow us to separate these concerns a little bit further. So the product that's generated by link to SQL, we want to actually hide that away. Now, this isn't necessarily a problem that you have with in Hibernate or the latest version of Entity Framework. They have the concept of PACO, or plain old CLR object. What that means is the objects that you're actually working with don't know anything about the data access technology that you're using. If we were to look at this guy, I think he has it. In here, you're going to actually see generated product. So we have a product class. It's got a whole bunch of gobbledygook all over it. This is all generated by link to SQL. In order to use this, you have to actually reference system data link and a whole bunch of other things. So this really muddies up our code base. So we want to try and get away from that. So what we've done is we've created a product in domain directory. This product becomes an object that can be used by all of our other layers. Domain can be returned, or sorry, product in domain can be returned by data access. By core, it can be worked with in our controller. So this really is a PACO object. In order to achieve this, especially in a Link2SQL environment, we've defined all the properties that we actually had generated for us by Link2SQL, and then these other properties that you saw that we had before. The other aspect of this, it's no longer a partial class. This class no longer adds to the product class that is generated by Link2SQL. What this allows us to do is pass this object around. Nobody has to reference our data access layer. Before I get into the how we did that, how we disconnected that, let's take a look at what our product service is. So we had get product, and you remember we had a little bit of business logic in there to check whether the string that was passed in was actually a GUID or not. So we're now actually taking care of that in the business layer. You'll see that if we do find that it is not a GUID, we return null. So there still is some processing required by our, let's see, this would be, what's this guy? Oh, I'm sorry, it's in the home controller. So when we are getting the detail of a product, we used to have that check here. Now we just have a guard clause to make sure that the return product is not null. And this is a navigational issue, but the business logic for determining is it an appropriate ID for a product is no longer occurring in our presentation layer. So that one actually makes sense because we had business logic that needed to be hidden away. The product search service is purely a pass-through layer. This is because we do not want our presentation layer to communicate with our data access layer. To achieve that, we need to add something within our business layer. Now, frequently people will ask, well, if you're just going to call directly to product search repository and pass back the result directly, why do we even need to have this class? And the reason being is that, again, because we don't want to muddy up the concerns of each layer, we want to actually have this buffer layer, if you will. But also, if you think, maybe down the road, the complexity of how to achieve a search requires some business logic. You don't want to have to go in and disconnect pieces all over the place just in order to put this particular piece of logic into the slipstream where it belongs. So by having this, we can easily come in here, add business logic without any problem. It doesn't impact the users on either side of our code. Therefore, we've isolated the rippling effect, and we can add to this all we want. It just gives us an extension point within our processing. The next aspect to look at will be product repository. So here we saw originally we had this concept of bringing in our data access. The thing that's changed in this particular case, because we've actually started moving things into their own buckets, we now want our data access layer to return our domain objects, our product. And in order to do that, we need to figure a way of getting a product out of the database through Link2SQL and a generated product object, map that across to a domain object, and then pass that out to our business layer and eventually to our presentation layer. Well, the easiest way to do this is most evident. People write it all the time. You have simple left-to-right mapping code. You say product ID from domain equals product ID from data.product ID. If you have a really complex object model or table structure, then this mapping becomes really complex. It's straining on the eyes, it kills your hands, etc. Also, when you go to change something down at the database level, that causes a huge ripple effect because you got to come in here and make sure that all of these mappings still make sense. So what you can use instead is a tool called AutoMapper. I would think the majority of you guys have probably seen this. This is a simple object-to-object mapping system. Don't know if I call it a tool or a framework or what it is, but essentially all you need to do is specify a configuration for what objects you want to map in what direction, and once you've done that, you can actually come in here and say mapper.map, and you have the source object, and you have the object you want to create, and it takes care of all the mapping. Now, there's lots of different variations that you can do here. AutoMapper out of the box will take all of the property names and match up things that are identical. It will also take care of some type conversion if you have a few changes there. So if you want to go number to a string, for example, you can do that. Now it also has much more complexity built into it that allows you to maybe take a really flat table which creates this monstrous object and split it out into multiple domain objects objects that you can work with. And again, you can map that going both ways. You can take an aggregate root with a bunch of stuff in it and flatten that out to an object and persist it out to your database. In order to achieve this, we have to set up our configuration. Well, and actually, step before that, even before you can do any of this, obviously you need to add a reference to AutoMapper. So what I've created here is a static configure method. When I initially run my application, whether it's an MVC app or a window format, you just need to come into an entry point of where your application starts, call into this configure method, and what we have is AutoMapper configuration.configure. And it's telling AutoMapper that I may have a domain product on the left, which is the source, and I might need to take that to a data product, but I may need to go the other direction too. And so what this allows us to do in our data access, when we are simply adding a product, meaning a domain object is coming in, we can map that out to a data.product, data access product, and then push it into our database. Or when we're getting a product, we can go the other direction. In this case, we need to actually map what we're getting from the database, which you see here, out to a domain product. So really easy way to translate LINQ to SQL's inability to have a PACO type infrastructure. Obviously, you may not need this with in Hibernate or Entity Framework, etc. Let's see how this impacts. So because we've moved a lot of this around, Home Controller now should have no, well, I think we actually covered that, it no longer has the business logic. What we'll also see is rather than going out to our data access layer, which would be the product repository, we go through our product service, and this will be our business layer, which allows us to add a product, which then communicates to our data access. I don't think anything in this case changed in the view. That is untouched. Any questions on this one? Again, there's nothing really to see when I run this application. The flow is pretty much the same, with the exception that we now run through the business layer, but there's no crazy complexities to actually see there.
Andrew, Nate has a question. He's asking, what if the product service is an ASMX web service? Then in the UI, you end up with the product proxy class. Will AutoMapper work in this case and map proxy to your view model product class?
So it's interesting you say that. So in the 7th iteration of our refactoring, how I'm actually going about distributing is to create a WCF service and to use a client, which is our own, call it a proxy if you will, that then takes the place of our business layer. So our home controller still calls out to what it thinks is a business layer based on a contract. The proxy class, or again tier, once we get there, will call out to our ASMX or WCF, etc. So we will actually cover that as part of this presentation. That particular implementation where you're thinking that the home controller will know anything about a web service, we won't go that road. Does that make sense? Okay. So I'm going to go back to my slides. Okay, so this allows us to move to physical separation. And by physical separation, I just mean we're creating new projects within our solution. They're class libraries in most cases. Class library generates a DLL for us. This DLL can technically be processed anywhere we like if we actually have built our application in the right way, which we'll get to. Simple definition, a tier is typically a physical boundary, like a module assembly DLL of code. A tier contains layers with similar concerns. Obviously, you can contain all sorts of different buckets of layers within this particular module. Tiers can run in different processes from other tiers, and tiers can be distributed to separate servers, so that's the ultimate different process. So why use tiers? Tiers can be ran in separate processes to isolate its impact from other processes and vice versa. So say you're working within the app domain of a website and you have multiple different DLLs, they're all running in the same process. You kind of create a problem there, and if you have horrible exception handling or something really bad happens, one particular module of code could definitely impact another module of code. Whereas if we start to distribute our application, and you'll see this frequently in Twitter, you'll try and do something on Twitter and they'll say Twitter's over capacity or something of that nature. The website is still totally functional and a lot of aspects of the site actually work. However, whatever it was that you did stopped working. It stopping its processing didn't actually impact the rest of the website. What you'll see here is the fact that we have a presentation layer, which is essentially where MVC lives. It communicates out to core, or our business layer. Some people call it BLL. That communicates out to our data access layer, linked to SQL in this case. They will all have references to our domain project. The domain project will contain all of our entities, and it will also contain all of the interfaces that we'll use later on. The fact that all of these guys can communicate with domain, and domain obviously won't be able to communicate with any of those guys, means that we can only put stuff in there that will be used, but won't actually have implementation of these other guys or use these other projects. Let's take a look at how that works. So we'll go into physical separation. So the nice thing about this is that everybody has probably had an application at some point of what we're looking at here. Whether it's a demo app, or maybe you have the concept of layers, or maybe you have the concept of tiers. Hopefully everybody will eventually come to the same path and see how inversion of control and structure map and how we can add distribution layers, or think about it, you can add any kind of layer. At the end of this, I'm hoping everybody will see some cool thing, whatever it may be. So what you're going to see here, first and foremost, we no longer just have a web application. So we have our web application. It is the default project. It is the process that all of these other guys currently run in. You'll see we have a domain project. The most important thing is the references within these guys. So in this case, we're not referencing link to SQL. I could probably remove these. They just come by default. We're not referencing any of our other projects. We don't have AutoMapper in here. Nothing special goes on in our domain. It's pretty much just a container. Currently, it just contains product. Later, we'll add to it. Core would be the next thing. Core will reference our data access, and domain. It does not reference web. Again, you only see these guys, but we're not actually using those. No link to SQL references. Those have all been hidden away from us. Data does reference AutoMapper. It's also referencing system data.link, which is what we're using for data access. It has no references to our other projects other than domain. Web is equally isolated. It only has access to core and domain. It also has access to AutoMapper because it has to go through all of our different tiers in this case and wire them up. So we'll take a little bit more of a look at AutoMapper. So how does this impact our application? What we're going to see in data, very little changed here. Actually, probably nothing changed. We're still passing out a product. This particular data access layer is now totally isolated. It just does its one simple task of getting some data and absolutely nothing else. This is one thing that does concern me, which we will start to isolate in that we're mixing a concern. Technically, product repository shouldn't have any idea of how our configuration mechanism works. So we'll move that out in a little bit. Next thing is to look at our product service to go further up the pipeline. Actually, that's complaining it's in the wrong namespace, but I'm not going to mess with it. Get products. We have our business logic. We communicate with the product repository. It's pretty much unchanged otherwise, other than it now lives in a different project. And again, home controller, which actually calls through all of this. If we look at What it's doing, it's still just calling into a product service, which calls back into the repository. The one thing that does change is how we wire these things together. Because our application actually starts here, we need to call our AutoMapper configuration so that it can set up the mappings of the data access and the web side of things. And so if we look at AutoMapper.configure, which is stored in core, it needs to know about our domain. It also needs to know about our data access layer. However, because we've put this class here, our web application doesn't need to know anything about this. If we tried to put this logic for configuration into our web app, we would still need a reference to data, which creates a problem, obviously. Other than that, no physical changes are going on here. Any questions on this one? I'm not going to run it again. I'll actually run this application once we get to the distribution concepts, because then you can look through the debugger and see that things are actually changing a little bit.
Dan is asking, how can we handle security in a sensible way with distributed applications? Do you have any tips for securing a distributed application that uses WCF with REST interfaces?
So there are a couple ways. What we'll see as the last iteration of refactoring, we will actually have full dependency injection. We'll be using structure map. What that gives us is the ability to compose how our objects communicate with one another. So rather than relying on true object-oriented principles where we have abstract classes and all sorts of different subclasses, etc., what we will do is actually compose objects together so that they can work in Orchestra. But the way we will do it is via structure map configuration. What that allows us to do, and this is kind of what the distribution layer will be built upon, is use structure map to insert different tiers, different ways of processing something. Now, these tiers will be interacted with via interfaces, and we'll see that coming up here. And what that allows us to do is create contracts that each layer or each tier communicates with each other through. And what that means is we can put in a different layer, a different tier that still operates on the same contract. And so if you extend this concept of presentation layer and core or business layer, data access layer, we could add a security layer, a logging layer, a caching layer, a distribution layer, and we don't have to add it across the entire application. Maybe we want to add a caching layer to our search pipeline. So we could create a tier or layer depending upon where this code sits, inject it in between the request process from our controller and our actual business layer. And what that would allow us to do is go out and fetch data through our data access layer, business layer, bring it back. As part of the hop coming back, we can create a cache, and then every other request after that can go through our cache. This is all very simple because what this essentially allows you to do, and this is a little bit off the topic, it allows you to isolate these new features that you want to do. You don't have to change any aspects of your application orchestration. You literally inject it in between these different areas of interfaces, of abstraction. So when doing security, totally depends. From a technology point of view, I don't have a specific answer as to use X. From an architectural point of view, it totally depends on what you're trying to secure. You can insert a security, we'll call it layers, a simple way to look at it, in between your home controller and your business layer so that none of your business logic actually gets executed. You could do it in front of and behind your distribution layer, whether it's ASMX and it's returning JSON, what have you. None of that necessarily matters. It's just a matter of identifying the point within the pipeline and what you want to secure. So I would return the question, what specifically are you trying to secure?
We have another question from Steve. Steve wants to know, do you think Structure Map is one of the better SOC frameworks?
So unfortunately, I'm kind of biased on this, not from a point of thorough research. I have used Structure Map not as long as it's existed. I think I started using it a year after it came out. But in all of my time using it, I've never come to a point where I couldn't do what I wanted to do. Now, having said that, the new company that I'm working with, they're not big on open source, so they're actually looking at using Unity. And what you should probably do is go out and take a look at, gosh, what did I look at? Structure Map, Matrix, Unity, something like that, and it'll show you just a huge grid of all the features that one supports versus the other. Now, I have to suggest that if you're just doing pure IOC and you don't want to do anything else, you just want to be able to say, go get me this object based on this particular interface, and I don't care what else you do. Most of the IOC containers do that without a problem. It's when you want to start doing some serious composition of how things work, and this is kind of where we will get to. Say you want your presentation layer to communicate across to your client for your services, which communicates to your remote service, a WCF service, ASMX, what have you, and then that communicates with your business layer and your data access layer. The communication between home to the client of your service is, say, iProduct service. And we'll see this actually. Then that client uses its own little proxy. It's just standard WCF or however you want to communicate with your web services to communicate with a remote service. That remote service then wants to communicate. It again says, hey, Structure Map, get me the appropriate instance for iProduct service, and it will return an instance of your business layer in this case. This is all easily handled in Structure Map. From what I've seen, and this is still a totally simple scenario, from what I've seen, the more complex you want to compose the orchestration of your objects, the more other containers start to fall down. And, again, that's purely me. I think Castle Windsor is probably the other one that you'd probably want to look at if you didn't want to go the Structure Map route. I do know that Unity is missing some features. I can't recall exactly what they were. But, again, I'm totally biased.
Okay, so...
Okay. Let me know when you're recording.
Yeah, I'm recording.
Okay. So we discussed tiers, and tiers was just the concept of breaking your code into physical modules, DLLs. These are physical pieces of code. They are multiple layers. Multiple layers could have multiple different aspects of code in them. What this definitely gets you, and obviously it gives you the aspect of isolation. It also gives you the concept of being able to distribute via versioning. So we see that we can distribute to another server and spread the load of an application. It also gives you the flexibility that you can have a marketing push that says, every week we're going to change our homepage. But you don't want that every week that changes your homepage to force you to deploy your data access layer. So what that means is you could just now bundle up presentation layer, deploy it. You can deploy data access layer, no big deal. So this is definitely a lot more flexibility there. I think we looked at that. So, okay, so what we're going to look at now that we have all these separate containers, using things becomes slightly more complex from a logistical point of view in that you now need to add references. You still have this concept of tight coupling, and by tight coupling in our business service, our business layer, we have the product service. The product service actually says, I need a new instance of repository or what have you. These concepts, anytime you see object foo equals new and then object, that the user, the class that has that statement in it, is tightly coupled to the object that you're instantiating. This becomes a problem in a lot of places. For one, now you have that refactoring issue. You may refactor that upstream or downstream object, and that refactor is going to ripple out to that dependency. That may force that dependency to change, in which case, because you're probably tightly coupled outside of that, you will also have another ripple effect felt. So what dependency injection allows us to do is, rather than creating these new instances of implementation inside of our class, we can create a constructor injection, which allows the user of our class to pass in any of the dependencies that that class needs to operate. Dependency injection, I'll read the definition, is a technique for supplying an external dependency to a software component. Dependencies can be manually injected or injected by a framework. This particular iteration, we're going to show manual injection. So what this means, in our case, we have the home controller. It takes a request in. Say it's the search request, so we have to call the product search service, and we pass in that string. The product search service needs to pass that string to the product search repository, and then we get that result back. That's dependencies all the way down. So what we're going to do is invert that concept. We know that the product search service requires an instance of a repository, so instead we're going to actually have the home controller create the instance, inject it into the search service, then the search service will use that injected instance. The nice thing about this is that we don't really care what's injected, because part of this implementation is we're going to use an interface as the type for the constructor, and we'll see this in a second. What that means is we are going to say that the product search repository actually has these methods based on this particular interface. Interface is just a contract, if you will. So I can create all sorts of concrete implementations that implement that interface. In our case, we have, I think it was search products. So I can create a mock product search repository that doesn't actually communicate to the database. Maybe it connects to an XML file or just has some mocked up data within the class itself, within that method, and returns out data. But what this means is the business layer, the product search service, doesn't need to know. It doesn't need to know that I'm working with the database, or I'm working with this mock object, or I'm working with a cache layer. It doesn't need to know that because you are passing in a product repository of some type. That type has the method that we need to use, and therefore it can invoke that method off of whatever type we passed in. This creates a lot more flexibility. Let's see, I think I went through this. So enables loose coupling. We no longer have direct instantiation of objects, therefore our coupling starts to disintegrate. Testing becomes easier because we can actually throw in mocks or stubs. Different complexities there. I don't know how into testing you guys are. Code isn't dependent upon the concrete implementation. This is the concept that it doesn't care what type comes in as long as it has the methods that it expects. So we'll go ahead and take a look at our code for this. Let's see. So one of the cores to what we're doing here, first and foremost, obviously we need to move out the tight coupling, the direct instantiation of classes from our classes. So in this case, product search service, we need to move out the product search repository. Now we could, let me open up product search repository or product search service. So we could move this usage of product search repository and just say use this class, product search repository. And what that means, it's still dependency injection. It's not as flexible. What it's saying is that I'm going to expect somebody outside to inject a physical implementation. That would technically work, and it definitely hides some of our problems or alleviate some of our problems. But by saying we expect an iProduct search repository, iProduct search repository is just an interface, which hopefully will open. Okay, so it's just a plain interface. It says that whatever implements me will have a method of search products, will return a list of product, and will expect a type of string. So I can create an actual product search repository which connects to my database and do all of this fancy database stuff, or I can create a mock, and that mock might just instantiate objects directly. Something cool to use there, which I don't have in my demonstration, is InBuilder. You can use InBuilder to generate some data and pass that out for your mock, etc. But at the end of the day, this particular class only knows that it has a dependency on iProduct search service, which is being passed in. We then set that to a field, and then at the time that this class is constructed, we set that. And then from there, we can just say, okay, based on my field, I know that this thing has been passed in. I have a working instance. I don't know what the instance is, but I do know that it has search products, and I do know that it will accept my search string. So the immediate question is, well, wow, where'd that new go? Somebody has to new up this object or instantiate the object. So the obvious first place to look is the home controller, because we know the home controller calls product search service. So let's go take a look there and see what's going on. So we'll look for our search method. There he is. So we have search. Oh, wait a minute. I don't have a new creation of product search service here either. So I must have implemented constructor injection here as well. So we'll look up at the top. Yep. So we have here more constructor injection. Oh, wait. No, I haven't done that yet. That would be the next session. The next class. So here we've actually moved up our product search repository. So we actually create an instance of that new product search repository. You'll see here that we do pass in created instance of configuration service, which is, I'll show you that in a sec. We do have a product repository, which also takes in the configuration service. Product service takes in repository. Basically, these are all the dependencies that each one of these classes require. Let's see. Oh, here we go. Product search repository. So again, each one of the actions or methods in this controller are dependent upon these fields, which are set at the constructor or construction of home controller. Now, when home controller is constructed by the controller factory in the pipeline, all of this happens. This is obviously the thing that we will address in our next iteration as to how can we get rid of this? How can we alleviate even this pain? We don't want to ever new up any instance so that home controller doesn't necessarily have to be aware of anything either, and we'll do that in the next thing. Let's look real quick at core configuration service. So core configuration service, recall that before we had configuration manager directly in our product search repository and product repository. That's kind of a mixed concern because how we access our configuration, whether it's via the .NET framework or we choose to have a homegrown implementation of config files, etc., that should all go within the business layer. So we've moved that into core. So if we look into product repository, what we're going to see here, iConfiguration service is injected, which then allows us to say configuration service get connection string. Again, this could be mocked out where we could swap implementations. One nice thing, so it gives you obvious flexibilities from a runtime of production environment in that we can inject caching, we can inject security. That's definitely a huge benefit. You can have a totally flexible application. People frequently only think from the production side of how my code will work, how efficient it is, etc. But also think from the perspective of the person working in the code. If the person working in the code can have a more efficient experience within their code, it's more enjoyable, so the guy's going to work a lot harder, but also it's much easier to maintain. You can see exactly what's going on here. Code's totally flexible. I remember I worked with Jeffrey Palermo once. He had implemented Lucene.net as a local caching environment for the developer's box. We actually had a cache service. I forget the name of what it was, but that cache service actually used Lucene to write stuff. When we moved it out to our testing servers, it used a different implementation. And if you were to move it out to a production server, you could scale out to Memcache or Velocity or something like that. But all of those flexibilities, both from the developer side all the way out to production, starts here by dependency injection, or injecting these instances of the usage. Any questions on that? No? Okay. So now here's where things really start to get interesting. Once you've gotten your application this far down the road and you've really started to embrace these patterns and concepts, what you can eventually get to is our next concept, and this is the inversion of control. Now there are lots of containers. Basically, it's a dynamic factory pattern, if you will. In a normal factory pattern, maybe I have a really complex object that in order to create this object, I have to do all sorts of fancy stuff. Well, we don't want the consumers of that object to have to know anything about that fancy stuff. So the consumer of the object can say, I need a new order object, so I'm going to go to the order factory, maybe pass in one or two things. It'll take care of the rest, pass me out a hydrated order object, and I can go to town. Well, a inversion of control container or structure map or Unity, etc., it takes that concept a little bit further. You don't have to actually create the controller or the container. You don't have to worry about all of that complexity. All you need to do is go into some form of configuration to say, if I ask for this particular instance by way of an interface or an abstract class, go over here and return to me an instantiated or hydrated object, I would say instantiated, not hydrated, object of this type. Now, the nice thing that I really love about Structure Map is as you go downstream, all these objects have their own different dependencies. If we look at our particular case, we have home controller, we have the product search service, we have product search repository. The search repository also requires a configuration service. The product search service doesn't require the configuration service, but it does require the product repository. Well, rather than having to go into my constructor for the product search service and say, product repository needs an instance of configuration service, so I'm going to pass into my product search service the configuration and the product repository. I don't have to do that. Structure Map will say, oh, you want an instance of product search service. I happen to know that the repository also requires an instance of configuration service. I'll go ahead and take care of that for you. Here's the product search repository that you need. Go ahead and start using it. If everybody is wired in and they're all using the constructor injection, all of this is just automagically happens for you. And we'll see that here in a second. So inversion of control, when the flow of control of the system is inverted in comparison to procedural programming. Procedural, instead of actually creating instances of stuff, that's what this is taking care of for you. Structure Map is a tool that helps with dependency injection and inversion of control, allowing us to remove dependencies and provide booster coupling in our application. Why use IOC? From my point of view, it definitely gives you the ultimate flexibility in your code. Again, this is the concept of composable code over a really large object graph or object-oriented environment. That's not to say you don't use object-oriented principles. It just doesn't need to be as complex as what you might need without IOC. Makes your code easier to test because you're no longer working on concrete types. You're now working on abstract principles. You're working off of the interface or the contract that you declare that you need. Therefore, it allows you to easily inject new layers into your code. Now, when I say layers here, I do actually mean you could inject layers or tiers where appropriate. Again, they're not the same thing. So what this means is I could inject a caching layer, logging, security, distribution. These are things that easily slipstream in. So say we're in a non-standards environment. Maybe you're an e-commerce application that's fairly small, so you get under the radar as far as a lot of regulations. Eventually you grow really big. Now all of a sudden you need to comply with various standards, so now we need to log every transaction. Well, rather than going into your business layer and saying, if this comes in, log it. If this comes in, log it. You can literally just snap in a logging right in between your order pipeline, and it will automatically happen for you. Any questions on the concept of it before we start looking at it?
No questions so far.
Okay. Okay. Okay, so the key thing here is Structure Map needs to know what you want to do with your application. It's very similar to AutoMapper in that it's a two-way mapping. In this case, we're not mapping properties of objects. We're mapping interfaces and types to concrete implementation. So in our case, previously we had generated an iProduct service. Product service implements that. So what we can do is go into our core registry. And this is one way, I guess I should inject here that, so StructureMap is very flexible in its configuration. You can use XML files, you can use attributes. I personally prefer to have this DSL, the Fluent configuration for StructureMap. The downside to this, it is a compiled configuration. So if I do want to change how this configuration works, I do need to come in here, change whatever it is, and deploy that particular piece of code. Whereas in the XML side, I might actually be able to configure it during runtime in production. Now, for me, that's a bad thing, and I would never do that. So I don't ever need that. If I'm making a change to my application, I will redeploy my application. There is a way to remove that concept in that you could put these configuration concepts into their own distributable DLLs, and then you could make changes to it and push out that code. So there are ways around that. To use the Fluent configuration, you just need to create your own registry class that is of StructureMap's registry, implements registry. Has core registry is my own thing, call it whatever you will. All I'm saying, real simple syntax for this particular type, this interface, iProduct service, I'm going to use product service. And what we're going to see in the next presentation where we actually create a distribution layer, I can use this in one place and use a different concrete implementation for this particular interface in another place. And that's what allows me to compose my pipeline. So in the front end, I can use my distribution layer. In the back end, I can continue to use my business layer. In the front end, I could use a business layer. In the back end, I could cache my data layer. Total flexibility there. Now there are some other aspects to this, so I create a helper class called Register Core. Basically I just kind of flip these around. Again, totally up to you on the naming structure here. The only thing that was probably important is that you do need to inherit from registry, and then you can go from there. That's what provides you this syntax. So what I like to do in a simple scenario, maybe I'm just registering one library, then I can just say register. It communicates with Object Factory, which is your entry point into StructureMap, and I pass in all of my registries. I could do all that right here. However, I find that when I start to work in a tiered environment, whoever my host application is, in this case it's the website, it needs to be able to call into its next neighboring layer. In this case, it's going to call into my business layer, but my business layer will probably need to call into my data access layer so that it can also take care of some work. So what we see here is in Register Core I have get registries, and what you'll see is a list of registries. Now because Core, or my business layer, also knows my data layer, I can communicate with data registry, and therefore I can hide the fact that I need to communicate there, create a list of registries and pass those out. Or again, I can just do my registry directly here, however we want to do that. At the end of the day, you do have to call it at the start of your application. Gosh, when I wrote my first book, I mentioned StructureMap, and the number one complaint, not complaint, but the number one problem was a 202 exception. What this means, and if you grab my code and start playing with it, odds are you will probably add a new type and you will get a 202 exception. All it means is that you have not configured a type. So you're making a request for an iProduct service, but you haven't said what kind of concrete type to do. So whether you use XML or attributes or this Fluent configuration, however you've configured it, you've missed a configuration when you get that error. So I've blogged about it. All you got to do is search StructureMap 202 and you'll find the answer to it. But that's the one thing that I frequently come across. Even myself, when I'm doing this, I might forget to do it because it's so easy. So in the start of my application, I am actually going to call into registercore.register, and the way that I have set it up My register method is a helper for me to actually worry about registering everything else. I can register data. I could snap in a new module of code, and I would probably have to put it in here as well. But that way my website can go ahead and take care of configuring structure map for me. Can configure it all the way up the pipeline as far back as I need to go. Let's see. Okay, so once we've done that, recall that we had product repository. I'll take you through this real quick. It is using injection via constructor, and then we're just using this field throughout the rest of our code. We then had the product search service, or product search I think we'll look at. Again, constructor injection, the usage of the field is what we actually use throughout the rest of our methods. Where we had a problem was our home controller actually had all of its creating the instances of the concrete types happened in the constructor. They weren't injected. That was a big problem. By using structure map, we can override essentially the controller factory that comes with MVC and say, in some cases, I want to use structure map to be my controller factory. Now, by that, I'm going to say, if a request comes in for the home controller, I'm going to look at my configuration. Structure map is going to look at its configuration and return controller. But because we're also using constructor injection in our controller, what you're going to see here is for controller, home controller to work, it needs an iProduct service and an iProduct search service. Now again, notice there is no concept of configuration service, product repository, product search repository. That was in the previous version. That has since gone away because structure map is going to take care of that for us. So we will look in the model. You can put this anywhere you like, whether it's in the core or in web. I put it here just so it'll be easier for you to locate. Structure map controller factory. Now you can find all sorts of different implementations on the web. Just search literally structure map controller factory. Essentially all it's going to do is we're creating our own implementation for a controller factory. We are implementing the default controller factory. All you need to do is implement a get controller instance. That requires the context and type that's being requested to be passed in. Using that information, I can say is controller type is null, meaning, let me look here. Then we can actually call out to structure map. Structure map will get an instance based on the type. If you recall, we're just passing in a type, and then we are casting it as a controller. However, if something else comes in, a problem that I frequently have, and a lot of implementations that you'll see in the blogosphere, is minus this catch concept here. Reason being, so if you use Chrome at all, Chrome, well, I use Chrome, I'm sure all the other browsers do too, they request a favicon or a fav icon. I don't always have that, and so it's something that's being requested through my pipeline that doesn't exist, and it causes everything to blow up. So you do need to make sure that you actually return null out of this guy. We're not returning an actual controller. We have no idea what the request is for, so we're going to let somebody else handle that in the process. That will allow resources that are being requested that don't actually exist to not also kill your application. Let's see here. And then if the type does come in, we can still actually go through our base controller for things that are not configured and try and pull them through the base controller instance or implementation. Let me see. I think that was the only thing in this particular guy. Any questions in this case?
I don't see any questions in the queue.
Okay. Okay. So now we're going to get to our distribution layer.
Andrew, we have a question.
Uh-huh.
Jamie is asking, isn't there a specific exception type to use?
Let's see. I guess if you wanted to throw an exception, but so a problem that we would have there, so say Chrome is requesting the favicon, or some user randomly requests a page that doesn't exist in your system, I personally don't want to capture the exception that I didn't decide to implement the favicon, so I don't want to necessarily throw an error. It's totally up to you as to what you want to do there, but if you want to constantly be throwing errors, in that case I would probably suggest you implement like the Elma framework, error logging modules and handlers, so that we don't actually bubble that up and see the yellow screen of death for your user. Totally up to you. Okay, so this is exactly the same application. It's still using structure map. The one thing that we're going to see that is different here, we're now going to inject a distribution tier. The reason I'm calling it a tier is that it's actually is created in two projects. To do distribution, it means that I need to actually take some unit of processing. In this case, we're going to take our business layer and put it somewhere else, whether it's in a different website on the same server or it's in a different server altogether. It could be in a different data center, what have you. It just doesn't exist within the scope of my application. Now, you might do this for a few reasons, not just to scale your application. Maybe you want to do it from a reliability perspective, in which case, again, you still need to distribute some processing of your application. In this particular scenario, the reason that I created a product catalog and a product search service as separate things is so that we can actually take our product search service and we're going to distribute that over the wire to somewhere else. Now, in this case, what you're going to see is here's our original demo app. And then we have another web application. So when I run these, it's going to create two instances of the Cassini server, therefore two separate processes. So this guy, the remote services, is just WCF. Now, it's just a regular web project. It's not a special WCF service, nothing of that nature. It just happens to have a WCF service in it. That guy can run anywhere. And technically, I could run that particular website in a cluster of 6 other servers. I could make that cluster redundant to another cluster, or I could have it load balanced in other ways. But it doesn't matter. It's going to be at some other address so that when my website calls out to this particular service, it doesn't know that it's not going to the database. It doesn't know that it's going to the remote services, and I'll show that. So in order to do distribution, this is one case where we need to actually create some way of proxying the request to this other place, this other location, but also we need to come up with a way to handle that request in this other location. So in that case, 2 projects. This could be ASMX, it could be WCF, we could have WCF as a service, we could have it as MSMQ, totally dependent upon what it is that you're trying to achieve. The semantics of it should be the same. What you're going to see in here is we have still structure map registries. We'll look at that in a second. But we have a product search service client. Call it what you will. The important thing is it implements iProduct search service, meaning it has a method of search products, takes in a string, returns a list of products. As long as that happens, we can then create whatever configurations we want. So we have a service client registry. This is just a naming convention I use. And so what it's going to say is if I choose to use this registry for structure map, when a iProduct search service is requested, instead of returning just product search service, I'm going to return my proxy to my distribution processor, my WCF service. Now the thing to note when configuring structure map, we still have to go through all the same semantics of when the app starts, we need to call something to configure structure map. It has gotten a little bit more complex because we're going to register our business layer. So think when we register our business layer, we are registering our product service and our product search service. That happened first. Well, when I call service client and configure it, it also has, I'm sorry, I'm looking at AutoMapper. I am a fool. So we're going to call register structure map, which will then come in here and then do what I was talking about. So business layer, get registries, gets a list of business layer registries and data access layer registries. They come into this container. However, I then call into register a new service client, .get registries, and I'm adding a new collection. Well, part of the registry in here actually says for an interface that structure map already knows about, I'm going to assign it a new type. I'm going to say that when somebody requests iProduct Search Service to actually go and get the Product Search Service client. So I've overridden my configuration at runtime. That means I could pull this out at any time, and this is in Global ASAX, so I could actually comment this out, and it will no longer run. And we'll see. In fact, we could probably do that now. So here I'm creating a collection of registries to deal with, and then I'm iterating through them to initialize them into StructureMap. I've commented out my service client. Now, I haven't tested this, so hopefully it will actually still work. Notice that we have two instances. We have our remote services and we have our website. We are not actually going to use our remote services this time. I believe I set breakpoints in here already. I guess we'll find out in a second.
Andrew, George wants to know if the application you're demoing will be available to everyone.
Yes, I think they're actually going to share all the slides and code. If not, I will also post it somewhere and write a blog post about it. So it'll definitely be out there. I'm pretty sure they're going to put it on CodePlex, everything. So what you're going to see here is we have the regular catalog. Now, we didn't hit our breakpoint because we didn't actually search for anything. So we'll search for bronze things. Now we should hit a breakpoint. Okay, so we're in our home controller. We've asked to search for things that are bronze. Product Search Service is the field that was passed in or via StructureMap. You'll notice as we look here, we're actually working with a Product Search Service, not the Product Search Service client. So we're actually going to go out here. Here we are in the Product Search Service. So this is all happening in a local instance in our website, and then we will return our list of products. Okay, so that, let's see. Okay, that worked. Because we're in Global ASAX, where is he? Let's see if this guy will let me. Nope, it will not. So let me stop. In production, you could actually come in here and fidget with this, and while I don't recommend that, you could do it. So what I am doing right now, and this is as simple as it is to inject this distribution, all of a sudden, for whatever reason, our search is bogged down. It's killing the performance in our web server. We need to distribute that out to our app servers. All I had to do was uncomment this line, and now we should see our debugging actually step through across to the other implementation. Now, the thing to note here, because we're running our application, parts of our application in two separate places, you have to do similar configuration. We're still going to use business layer and data access layer behind our WCF service, just like we normally would. Let me see. I think we will hit distributed application web remote services. Let's see. Okay. So we haven't actually ran that yet. So let's search for a chair. Okay, so we've hit our home controller. It has passed us out to our product search client. So we're using a different implementation of that particular interface. This is going to pass us out to our remote service. Which we didn't hit the global, but so we are in remote product search service, which is a WCF service in this other running process. That's then going to use our product search service behind the WCF service, which will then pass us back to product search service client, which will then pass us back to home controller, which then gives us our results. Now, the thing to worry about here, you have made a request from the consumer of your web application. You then made another request from your web server to another environment, wherever that other environment is. So you don't necessarily want to build distribution layers for everything and use them from day one. You only want to use them when the cost of having another layer in there that's this big outweighs or somehow helps the performance of your website. So by distributing the processing of X, the jump over to WCF and the amount of time that that request makes is actually less than having all of the processing that happens right on your web server. So let's go take a look and see some of the other stuff in here. So our product, remote product search service, it again is kind of like the pass-through that we did in our original business layer, where our actual product search service just passed a string along. This guy is calling structure map. Let me get rid of these guys. Bye-bye. So this guy's calling structure map, which means if it's calling structure map, we had to wire it in our remote services project. So here's our remote services project, global. So same thing. Now in this case, we don't have any need to call into our service client. You could do that, I guess. You could distribute your distribution. There might be a reason for that. But in this case, we do need to register our core. We do need to register AutoMapper. These are dependencies that our application, no matter where they run, they need to have these things taken care of for us. Let's see. Well, that's interesting. I'm calling register core twice. I don't know why I'm doing that. I think that's a faux pas, an oops. Yeah, okay. So this guy is just calling out. Notice we don't have a structure map folder with different registries. We're actually calling out to our business layer and our data layer from the business layer. So this acts very much like another presentation layer, if you will. However, we know that's not actually the case. It is a segment of or a component of our business layer, if you will. It's just a different way of distributing our processing. We would never have a UI that would sit on top of this. Now, that's not to say that you couldn't. Technically, our website is the consumer of this by way of our proxy client. Let's see, and then there were a couple other concerns that I need you to, this is more for working with the projects that you would have to figure out. This particular iteration of code is the only one that actually communicates with my SQL Express installation. All of the other previous projects had an app data directory directly in their demo code, and that was registered in real time, attaching the database file to the system. The reason being is that I can't attach to a file in my web directory via my web application, then call another web application and have it also attached to that. That obviously won't work. Just something to be aware of. I think that is it. How are we doing on time? Perfect. Do you guys have questions at this point?
Andrew, Nate has a question.
Okay.
In the latest example, using the AutoMapper, did you convert the proxy product class into a view model class or in a domain class?
Good question. So because product search service client is the one that's actually implementing our interface, what we're going to see is, where did I do that? Right here. It's the one that actually has to return the domain product. So there is a couple ways you can do this. WCF out of the box, if I just want to create a project and add a service reference to that particular service, it will create its own set of stuff. So what you'll see here, search products returns a product of its own type, I believe. Let's see. What am I calling? Yeah, so what you'll see here is returning MVC Conf, distributed app, service client, service reference 1 product. Because I'm not actually using interfaces for my domain, that product is totally different from the product that the rest of my application expects. Having said that, there is a way to go through and modify WCF so that you actually have your own proxy, you have your own bindings, therefore you can return interfaces and your own products. I didn't feel that that necessarily fit the scope of this talk, so I am actually using AutoMapper configuration in my service client to say that I'm going to take a service reference 1 product and map it to my product, in which case you'll see in here, AutoMapper configuration, where is he? Right here, core AutoMapper configuration.configure, service client is where that guy's happening. Good question.
Andrew, we have one more question.
Okay.
Dan wants to know, at what point would it be important to use the service bus in the solution?
Another good question. So a service bus is another way of distributing your application. I do not have a whole lot of experience working in that type of environment. Service bus is totally different in that what I'm doing here is still asynchronous, although it could be asynchronous requests. These requests kind of hop along through my application. Service bus, I might actually post a message to a service bus. My application has no concept of what's going to happen to that particular message. Other things will within the bus, other concepts, other applications, other processes will subscribe to that particular type of a message. They may perform operations on it, put the message back on the bus, somebody else will grab it, and then eventually maybe I return, maybe I don't to my application. So totally different style of processing. That is also another way of distributing your application. The only instance I've had is working with BizTalk. It was one-way communication where my e-commerce app posted a message to BizTalk, which is another style of bus, and then from there it would actually translate that message and push it into, I think it was SAP at that time. That was purely one-way communications. It's not as fast from my understanding. It's not that I'm going to post a message to the bus and immediately get that response back. That's generally not its usage. And that's the total extent of my knowledge in a service bus.
Andrew, Nate has one more question. Validation. When the domain lives in the web service tier, would you suggest attribute-driven in the view model class? Other solutions? Here there is a need of validation on three places: service tier, UI server side, or on browser side.
So I actually do very much enjoy the attribute concept that comes with MVC. Well, I guess just in general with .NET Framework now. So yes, I definitely use that. I have used what is the standard validation that works within MVC so that I can validate my model and automatically generate the description of what the error is. I can use regular expressions, etc. So it's kind of the same concept that I'm isolating it into the domain, much like I was doing the formatting of the dollar amount. I do like the validation there because that same validation can be communicated to the UI. And now it's not processed on the UI, it is processed on the server side. I believe there are some jQuery frameworks. You can also use, XVal and JSON or jQuery validation, I think, in which case then you can actually do some of the processing client side as well as server side. There are other aspects, and this is where maybe you plug in a security layer, etc., for other types of validation that aren't necessarily just validating your domain. Those probably would not go in there. This would be purely concepts of domaining or validating your entity, your domain itself.
All right, no more questions at the moment.
Okay. What time are we? I'll hang around for a couple more minutes and we can see. I don't really think I have anything else to show in here. Oh, I guess I should probably go back to my slides and finish that up. Okay. Oh, we never even got there. Distributing code with WCF allows us to put a segment of our code on the new server or clusters of servers. Distribution can be achieved by adding remote service and the service client that we saw. These two tiers can be plugged in and pulled out. Now this can happen for distribution, caching, and several other types of different ways of processing. They don't necessarily impact the unit of processing that you currently have. They are totally separate types of functionality that you can essentially dangle into your application and have everything magically work like we saw with the distribution layer. Let's go here. So a quick recap, it's all very simple. So obviously demo apps are bad. I think the majority of us know that. However, we still use them. Hopefully we'll stop doing that eventually. It's separation of concerns and single responsibility. This is the idea that we want to put things into buckets. The smaller the bucket, to most, usually the better. You can, however, be very, very anal with this concept, and that might create some complexity. I still feel that your code base will be better. Logical separation is just the idea of creating physical boundaries within the same process of your code. This generally happens within creating namespaces, isolating different classes into different folders. Physical separation is the concept of taking these layers and maybe breaking them out into physical projects or DLLs, assemblies, modules, depending on what you're talking about. Once you get into these tiers, you can then obviously deploy them separately, which is nice. It's a versioning issue. It's not necessarily distribution. It's one step closer. Dependency injection allows us to remove all of our tight coupling. No longer does one implementation have to necessarily know about its dependencies. It doesn't have any idea what a concrete type is. It works purely off of interfaces, off of contracts that it wants injected in. Inversion of control, structure map in this case, it's a container that essentially is a factory, if you will. You can request of the factory an instance. Based on the configuration of that factory, you will get a concrete type back. However, because we're injecting that concrete type, our application doesn't necessarily ever need to know what it actually is. It just knows that it has a certain set of functionality as described by the interface. Distribution with WCF. The thing I like about this demonstration is the word distribution with WCF, that could just as easily be caching layer or logging layer or security layer or any number of things. The nice thing is, it doesn't mean that you have to take a whole module. We didn't take our entire business layer and use that functionality behind our WCF service. We do have to deploy it. You would deploy that same version of your business layer in both locations, both instances, both servers. However, you can configure at the consumer end which sliver of that code. So now we're talking a layer, or more specifically a segment of code within a layer that will be used in that distribution or logging. We can do the same thing in logging and security and say anything in an order pipeline will use our logging infrastructure. Anything in an order pipeline might use our caching infrastructure. Different ways to find me. I'm currently writing a book on ASP.NET MVC. It's totally a cookbook format. It's not about frameworks. It's not about use Microsoft's way or use Fubu. It very much goes into here's a problem, here's how I suggest you address it. It does cover structure map, controller factory. It does cover all these patterns we've talked about. It goes into all sorts of different open source validation tools and so on. That is an open public review, so you can go to mvccookbook.com. That will give you a link to Google Groups where you can actually get all the material that I've written so far. You can let me know if you totally hate it, and I'll definitely change it. They do want you to go in to speakerrate.com and rate our presentations, if you could do that. And then if you want to find me, just search for Andrew Seymour, and I'll pop up all over the place. Email aseymour@hotmail and Twitter @aseymour. And I believe that is the end of my presentation. Does anybody have any questions? It is 3 o'clock. That was perfect. Okay, guys. If you have any questions, do feel free to contact me outside of the scope of this, and I have no problem communicating with you.
Andrew, thank you very much for that wonderful session, that 2-hour session on distributed apps in MVC. We all learned a lot from your session. Thank you very much.
Yes.
This presentation was recorded at MVCConf. For more content like this, go to www.mvcconf.com. This presentation was recorded at MVCConf. For more content like this, go to www.mvcconf.com.